back to this video on raster data. In the last video, we talked about vector data and the difference between the vector data and the raster data. We also took a look at what the vector data looks like in our QGIS software. Now we want to look at more in-depthly into raster data. We established that the raster data structure is made up of pixels, just like in the image here on the right of my screen. So every raster image is made up of tiny pixels, tiny square-like pixels that makes up an image. If you see here in our last, we talked about these tiny boxes. When you zoom in really much, you begin to see boxes, and those are pixel elements of a typical raster data. And also, we are going to delve into our QGIS software to look at examples of raster data, and also we are going to do georeferencing. Okay, georeferencing is the process of defining the exact coordinate, all right, of that image. You know, most raster data do not come with coordinates. Of course, there are pictures. You know, when we talked about sources of raster data, we made mention of aerial photography, drone shots, and satellite imagery. Satellite imagery usually comes with their coordinates. So if you put this file into your QGIS software, you don't need to georeference it. But the ones that will now require georeferencing are those aerial photography or just images. All right. And right now we'll go straight into our QGIS software to see examples of raster data, and we'll also go ahead to georeference them. So right now, let's head to our QGIS software. And there we go. So here is our QGIS software, and let me add our, now notice in the last, we were using the vector layer, but now we are shifting now to add raster layer. From your layers menu, you come to add layer, and you click on the add raster layer. Now, okay, you navigate to your folder. I have my folder here, and this is an example. Let me just add it. Okay, it has been added. This is an example. This is an example of a raster data. And let's try what I explained about zooming in. Let's zoom in. Of course, you begin to see. So these are pixels, and all these pixels put together makes up a raster data. That is the very clear difference between vector and raster. How they are data structure. Okay. So I think we don't have need for this now. I'm going to show you another example of a raster we want to use for the georeferencing, and right away I'm going to add that one now. So let me close this out. Okay, yeah, here we go. And now this, let me get rid of this. Now this. So of course it gets added on our screen. Now notice there is a question mark here, which means that this layer has no coordinate reference system set. It is just an image, it's just a picture, right? And we can't work with this because it does not have defined longitudes and latitudes. Okay, so right now what we are going to do is georeferencing. Some people call it registration. So when you hear registration, it's just the same thing as georeferencing. They call it map registration. Okay, and this kind of image is a scanned image. It's a scanned image, and we need to give it its longitude and latitude so that we can use them. And I'm going to show you shortly. So right now we can remove it and open the georeferencer and go ahead to georeference it and then get to add it back. Right now you go to your menu bar, and here is the raster, and here is the georeferencer. We get to open the georeferencer. Let me make it like this so that I can have more user experience, better user experience. And I'm adding our georeferencer. Let me get rid of this. I don't need it back. I'm adding our raster image, and this is it. Now, how we are going to georeference this file, we will need to find up to 4 known points on the map. 4 known points. This is a map of a state in Nigeria, Akwa Ibom State, the state of Akwa Ibom. And we need to find known points here so that we can give this file an accurate coordinate system, an accurate longitude and latitude boundaries. All right. Now, for us to do that, since it is already a map in itself, we have some information on it. We have, these are coordinates. This is longitude and is numbered from west to east. These numbering, these are longitudes. These are lines of longitudes, and they run from east to west. Okay, and of course these are latitudes. These numbers here, this is 5 degrees 30 minutes, and over here 5 degrees 15 minutes. So these are latitudes, and latitudes are lines that run from south to north. Okay, so now we are going to use these known so for example, this point now, this point where my cursor is now a known point. Why? Because this is longitude 7 degrees 30 minutes and latitude 5 degrees, this point, latitude 5 degrees 30 minutes. You see there's an intersection of x and y. So this point is an x and y, and x is longitude and y is latitude. So this is the longitude and this is the latitude, and this makes it a known point. Okay, now we have a knowledge of some known points. We can look for 4 known points and we use it for the georeferencing. So for the course for this illustration, I want to use this point as my number 1 known point, and this place as my number 2 known point, and down here I want to use this place as my number 3 known point, and this intersection here as the 4th known point. Now, this is actually a tedious one, but to be a very good GIS analyst, you need to understand georeferencing or map registration, and that is what I'm showing you. So to save our time, I did a little calculation to save our time. Now we want to use longitude and latitudes are displayed in different formats. We have degrees, minutes, seconds, and we also have decimal degrees. However, this scanned map came with degrees, minutes, seconds here will actually be 0 because it's not added. So degrees, minutes, but we need to convert this to decimal degrees so that we can use them. Okay, so how you do that is, let me pull this up. So I'll just show you how to convert from degrees milliseconds to decimal degrees. How you do that is, this is already 7 degrees. You can write down the 7 here. You can write down that 7 here. You see? But what are you going to do with this 30? So what you do is you divide 30 by 60. So 30 divided by 60 is 0.5. And you now add 7 plus 0.5. And that gives you 7.5. So that is how to convert from degrees, minutes, seconds to decimal degrees. The same thing for our latitude, which is 5 degrees 15 minutes. If you see here, we bring down the 5 here, then we divide 15 by 60. 15 divided by 60 is 0.25. Now you add the 5 plus 0.25 and you have 5.25. So that's to make the conversion. So for the georeferencer in QGIS, it makes use of decimal degrees. That is why we needed to make the conversion. All right. And of course, we have our 4 points already here. Point 1, 2, 3, and 4. So let's go ahead and georeference our map, our raster file. All right. Let me shift it a little bit so that I can have more space. Let me zoom out now. This is the complete file. This will be our point 1, point 2, point 3, and point 4. So let's go ahead and zoom in. So for our first point, you need to zoom in clear enough so that you do not make a mistake. So you head over to this yellow, this add point here. It has yellow color here. You click on it. You take your cursor to that intersection and you click on it. Okay, now you need to impute your longitude and latitude in decimal degrees here. So we pull up our node. I think it's best to write it in a paper so that you won't get confused. So we now bring in 7.5. 7.5. The next one is our latitude now. Oh, this was why, my bad. Our latitude now is 5.25. 5.25. Now you click OK and it gets added here, and the point gets added here. Now notice my cursor is still showing that it wants to add, but I can't scroll easily like that. So be careful to return your cursor to pan so that you can move the map without accidentally adding any point you get. Except you are using a mouse, you can wheel the mouse to zoom in and out. So as we said earlier, this is our second point. So let's zoom in. If you zoom up, if you check what is here, this is 8 minutes 15 seconds, which we already have the conversion. So let's just go ahead and finish this up. Since we know the point, let's go ahead and run it. Okay, that is close enough. Okay, so let's pull up our note again. And of course, we have 8.25. That's it. So for our latitude, we have 5.25. We click OK to add. It's being added here. Now I'm returning my cursor so that I can pan out. So let's head to our third point. This is our third point. It's loading. 4 degrees 45 seconds, and up here is 8. Let me just check it out again. Yeah, exactly. 7 degrees. Up there is 7 degrees 30 seconds. For benefit, if you are in doubt, you can just zoom out again and head right to the top. Okay. Yeah, that's correct. So let's go ahead and add our third point. Okay, it's right here. So here we go. And let's pull up our note and let's go to the control point again to activate our cursor. And we click at the intersection to add it. And now here we go again. Our longitude, which is X, is 7.5. Our latitude, which is Y, is 4.075. That's 45 divided by 60 is 0.75. So that's why we have 4.75. Oh, thank God I found this. Okay, great. These errors are not good. So you want to have accuracy in your work. Perfect. Now we are almost done. So we are heading over to our fourth control point. Here it is. Okay, you can zoom in well enough so that you can do what you have to do. And now we click on the add control point, and then we pull off our note again. I'll just go ahead to add this 8.25 and then 4.75. And there we go. I'm cross-checking and they look good. Now I can change my cursor back. Now that we've done this, we do not just go ahead to run. We do not go ahead to run the georeferencing. However, we need to check our settings first. When you come here, there are different things, but polynomials 1 is just good enough. Nearest neighbor is perfect. And then this is where you get to decide where you want the new base map that has been georeferenced to be stored. Okay. But I think I love where it is already. It's all just here with the other map, so that's fine. Now I want it to load automatically into the QGIS once it is done. And now let's click OK. Everything is fine. I haven't run it yet. So now I'm going to click Start Georeferencing. So it's not going to take long. It's running the registration or georeferencing, as you may call it. And I think we are done. We are done, successful. All right, so let's head to our application. And here we are. We have our map accurately georeferenced. Okay, we have it. So if your map is distorted, if it turns upside down or it looks smaller, so there was something wrong with your georeferencing. It's either the control points were not accurate, or it's either your longitude and latitude that you added were wrong. But here we have our accurate map georeference. So we can just do a little test to know if this is actually correct. So I'm going to pull up a shapefile that represents this location that has been georeferenced already to see if it will sit properly with this map. All right. So I think I still have them as zip files. Let me just go there and look for one. Okay. 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 I think I know what. Let me do that. Let me add the map of Nigeria, because this state is in Nigeria, and we're going to see if it sits properly when I extract Akwa Ibom state out of it. Don't worry, all of this we are going to show. We're going to learn it together. So now, back to layer, add layer, vector, and this is date. This is Nigeria admin 1, that's state level map. Okay, if you see, okay, in that case, let me just remove the colors and let the boundaries stay. And let's see how accurate our georeferencing was. Already, to let you know, this shapefile has already been georeferenced. This is a polygon shapefile. This is a polygon shapefile. So now let me just remove the color. Let me make it totally transparent. And let me increase the outline. Let me make, okay, black is fine. Okay. It appears one of these map is, okay, notice it sat perfectly well. Perfectly well. Did you see? It sat perfectly well. It sat perfectly well. Perfectly well. Perfectly well. Perfectly well. So I think what you see here is probably this part has been given to the other state, and this part belongs to another state, maybe in the most current map. However, our georeferencing was accurate. All right, well done if you got it to this point. In our next video, we're going to consider topological errors. We are going to digitize and consider topology errors. Okay, see you in the next video.